how chemists can contribute there. These are all matters of survival, whether it is matters of crop, pest protection, medicine, new medicine, and something as simple as water, good quality water. Everywhere, chemistry remains significant, and it will remain significant forever. So this is the branch, this is the science that we are teaching our children, teaching our next generation, that this is an exciting science. And what is exciting in chemistry? What is exciting in chemistry? It depends on how you internalize concepts, internalize, visualize, and deal with and interact with. Let me be slightly by 1% philosophical here. Two aspects from philosophical point of view. One is about interaction. Each one of us interact with living and non-living entities. Think of it. You are interacting with the room. You are non-verbally interacting with another person, which is me, because I am given the mandate to speak to you. So you are interacting. And you are sitting on a chair, you are interacting with the chair. But you are not noticing it, because your synaptic junction is progressively discarding the sensation of touch with the chair, because it's an unimportant redundant signal, so you don't sense that you are sitting on a chair. But the moment your attention is brought back to the fact that you are sitting on a nice cushioned chair, then you will pay attention for a fraction of a second. So you are interacting. All of us are interacting with numerous living and non-living entities all the time. Interaction. Second aspect is that we see some sort of a connection with our surroundings. We seek evidence. As scientists, we seek evidence. So how can we bring seeing is believing into the curriculum, into the learning, and promote and provide a platform for learning? And this is where the title of this competency-based learning with multidisciplinary approach. So I would bring this interaction and try to amplify it. Now, fortunately, not from philosophical perspective. There is a branch in philosophy called ontology. It's the entire ontology deals with interactions. Okay. So now the multidisciplinary approach in chemistry learning is, I brought some models. This is just to show, like, of course, many of you will recognize what is this? Ethane. And how many of you use models if you were to teach something about ethane or something about a tetrahedral carbon? How many of you use models in a classroom? Okay. Your school, I believe, has models. Now, a model typically in a classroom setup is in the hands of teacher or in the hands of students? Hands of students. Very good. And each kid in the class gets to touch the model. Yes, you ensure that they get to touch the model. Now, when you have a compound like this, which is of course CH4, very easy to say, CH4, and you tell many things about this geometry, tetrahedral structure, and so on. So I will tell you what I typically do in